Hey everyone, it's Gummy Dragon, and welcome back to another paleo ASMR video. If you don't know me, I do paleo art. I create original dinosaur characters and other prehistoric animals too, and I combine them with food, fruit, flowers, cute things, and generally use accurate, up-to-date science as a part of my work. So today I thought I would read something to you guys. So this is a National Geographic issue. It's one of the more recent ones, and it has a bunch of new up-to-date stuff in here about dinosaurs. And of course we have this beautiful Spinosaurus on the front cover because this guy is always changing. There's always new information, and by the time this video goes up, there is another paper coming out that has even more information. So who knows what's going to happen to this guy. So in this issue, we're going to meet scientists in the field, view cutting-edge technology, see dinosaurs that survived. It is a new look at the prehistoric icons. Yeah, and I got this at Whole Foods a month ago. I don't know if it's still available or not, but you know. Dinosaurs. And so I'm going to be doing soft spoken for this video because I just thought it would be easier for people to listen without me whispering the whole time, so I hope you guys enjoy. So let's get started. Alright, let me make sure if you can see that. Yeah, it's nice and crisp. It doesn't have much of a bend to it yet, so Dinosaurs, a new look at the prehistoric icons. So what we have here is a large theropod skull with a paleontologist looking on the underside of its mouth, like at the top of its mouth. So in this video I probably won't read all of these because there is a lot of content in here, which is great. So if you guys like the part 1, please let me know and I would be happy to do a part 2. So right now what we're gonna read is just part of part 1, probably a view of dinosaurs like never before. And I'll probably read the introduction just because. Okay? Introduction: Dinosaurs Redo or Redo. At its heart, our understanding of dinosaurs still hinges on finding fossils, an endeavor that remains surprisingly low-tech and involves mostly pickaxes, brushes, and brow sweat. And there's never been a bigger boom of fossil discovery than right now. On most days, there are multiple fossils unearthed around the world. On average, new species come to light every 2 weeks. And when those fossils get into a trained scientist's hands, that dino's whole world can open up. All of these new fossils offering multiple looks at the same species or filling in missing parts also mean previous mistakes or misconceptions can be revealed and corrected. Sometimes whole new species emerge from the process. But what makes modern paleontology particularly exciting is that it involves not only new things, but also new ways of seeing things. High-tech tools and interdepartmental partnerships reveal what we didn't or couldn't know until now. In addition to helping unravel fresh out of the dirt fossils, these new tools are inspiring fresh looks at decades-old fossil discoveries, down to the most minute scale patterns and feather stumps, the hardened remains of a last meal, and genetic materials. As technology keeps evolving, computerized tomography or CT scans will get better than even the hair's width they can show today. Digital renderings will reveal more precise movements, and troves of genomic data will link the past with the present. The reconstructions continue to lay fresh, ancient worlds at our feet. These same high-tech tools and imaginative research partnerships are unchaining the doors to what we can do, what we know about the world dinosaurs lived and died in. Digital reenactments can compare cataclysmic meteor impacts to apocalyptic lava spurts and help determine what took down the dinosaurs all at once. With all this in hand, paleontologists are rapidly rewriting what we know about the ancient beasts, how they moved, how they aged, and if they camouflage their eggs, or if they use feathers and head frills to perform elaborate mating rituals. Welcome to a new golden age of dinosaur discovery, where reimagining is every bit as important as seeing something for the very first time. And I'm very lucky to know many paleontologists and the amount of times that fossils have been recontextualized, even though they'd been described already. What they thought was this actually is this. It's an amazing science, a very inspiring science, that thrives off of just wanting to know. And I find that very uplifting. Okay. Part 1. A view of dinosaurs like never before. A view of dinosaurs like never before. And what we have here are some theropods again. Dromaeosaurids, I believe. Deinonychus. Yeah, it's Deinonychus here. They've got these nice blue eggs. High-tech tools such as CT scans and 3D renderings are widening the notches on paleontologists' tool belts. They are helping detail Africa's water-loving Spinosaurus and cracking the mysteries of dinosaur eggs. We love puns. Of course, they had to put one in there. All right. So we're going to do a couple of articles, and I might skip around. I have a few that I want to show you guys in part 1. We gotta read the Spinosaurus one. Why would we not read the Spinosaurus one? But I do think that the Reimagining Dinosaurs one is a really good one to start off with. I've already read this, so sorry I couldn't wait for you guys. So, Reimagining Dinosaurs. Oh, that's a big O. And this is a Microraptor, I believe it says, with the feather imprints here. It's just so amazing what we can see in fossils. It's just so fascinating. But let's get to reading. Our understanding of dinosaurs is seeing a revolution, one fueled by a wealth of fresh fossils and innovative research techniques. The resulting scientific bonanza is forcing us to rethink popular visions of these ancient animals. For several years, scientists have unveiled an average of about 50 new dinosaur species a year, a pace unthinkable decades ago. The updated menagerie ranges from pint-sized flyers with bat wings to long-necked herbivores that were Earth's biggest ever land animals. Medical scanners, particle accelerators, and chemical analyses are letting researchers virtually separate rock from bone and see fossils' tiniest hidden features, from the colors of dinosaurs' eggs and the feathers to the shape of their brains. Our Dino Encyclopedia now includes unprecedented details on how these animals were born, grew up, and lived. With these tools in hand, scientists today are not just overhauling our pop culture notions about dinosaurs. In a sense, they are bringing these remarkable creatures back to life. When it comes to dinosaur discovery, quote, "I do genuinely think the golden age is right now," end quote, says University of Edinburgh paleontologist Steve Brusate. It's fitting that dinosaurs are so persistently captivating for 150 million years. They dominated landscapes across ancient Earth, and they lived on what are now all seven continents. Dinosaurs were hugely successful during their reign, adapting into a bevy of shapes and sizes. Brusate and others estimate that scientists have cataloged more than 1,100 species of extinct dinosaurs. And that's just a subset of species that once lived, because fossilization occurred in only a few environments. Western science has formally studied dinosaurs only since the 1820s, but what we've learned reveals a lot about how land animals are affected by our ever-changing planet. And then we'll read this really quickly before going on. Paleontologists are rewriting what we know about the ancient beasts through innovative scientific techniques and a flood of recently discovered fossils. As continents drifted apart and recombined, and as temperatures and sea levels rose and fell, dinosaurs persisted. What lesson can we take from their responses and resilience? Telling such an epic story requires a worldwide hunt for dinosaurs' bones, and from Alaska to Zimbabwe, paleontologists are delivering as never before. Interdisciplinary lab experiments now define dinosaur research. Modern computers let scientists crunch through huge data sets of skeletal features and build dinosaur family trees. Close examination of bone slices thinner than sheets of printer paper reveal in detail the length and timing of dinosaurs' growth spurts, and with the same models used to forecast climate change, paleontologists can virtually sling an asteroid at Earth as it was 66 million years ago to watch dinosaur habitats shrink in the resulting apocalyptic winter. Before I continue, it is amazing that I have lived long enough so far that it has gone from 65 million years ago to now the correct timing is 66 million years ago. Isn't that so cool? And here you can see, we have a Spinosaurus sculpture in process. Probably. I mean, it looks life-size, and it doesn't even have the head. What an amazing dinosaur. Scientists today are not just overhauling our pop culture notions about dinosaurs. In a sense, they are bringing these remarkable creatures back to life. And not in a life finds a way kind of way. But let's continue. Few technologies have been so profoundly altered. Our view of dinosaurs as medical CT scanning, which is now a standard in the paleo toolkit. We've been able to pull all of these extinct bones into a computer where we can do things with them, says Ohio University paleontologist Lawrence Whitmer. We can reconstruct missing bits and do crash tests and run simulations and better understand how these animals actually functioned. Scanning also eliminates a past trade-off, whether to sacrifice a fossil soft tissue imprints to whittle down to bones. Stories abound of dinosaur skin impressions being ground to dust during preparation. Now researchers virtually cleave bone from rock. Quote, "It does make you wonder, what things have we overlooked or bulldozed through?" says Mark Whitten, a paleo artist at the UK's University of Portsmouth. The field's modern sense of caution has yielded an avalanche of discoveries. Recently, and of course they cut us off. And here we can see just an example of what they are CT scanning. This one just happens to be a modern animal. I mean, technically crocodiles are also prehistoric animals. They've been here a long time, just like sharks too. So yeah, we've got this Siamese crocodile carcass. And they want to reconstruct the internal anatomy of extinct dinosaurs. Yeah, this is what a CT scanner looks like on the inside. Very cool shot, like photography, how it's composed. National Geographic always has beautiful photography. Okay, we will get back to the dino brains because I find it so interesting because I didn't know this when I read this. So we'll definitely read this, but I at least want to finish up what we were reading. Whitmer used CT scans to show that major groups of dinosaurs evolved distinct cranial air conditioning systems to keep their brains from overheating. Armored dinosaurs, such as the ankylosaur Euoplocephalus, relied on their nasal passages, which evolved into ducts. It's a hard word for me to say. Ducts, shaped like crazy straws to shed heat as the animal breathed, cooling the blood destined for the brain. By contrast, large predators such as T-Rex vented excess heat with large snout sinuses, like blacksmiths working bellows. The dinosaurs flexed their jaws to force air in and out of the chambers, causing moisture to evaporate and wick away heat like sweat on a summer day. CT scans also can give us a sense of how dinosaurs moved and changed as they grew. Using X-ray videos and computer animations of alligators and birds, the University of South Florida's Ryan Carney built 3D models that revealed in 2016 that feathered dinosaur Archaeopteryx flap its wings in a way that enabled self-powered flight. Self-powered flight. Isn't that amazing? Meaning it can, like, just like birds today, how they can take off. And to understand how the Patagonian herbivore Mosasaurus grew up, Argentine researcher Alejandro Otero assembled scans of the dinosaur's bones in a computer to simulate its stance at different ages. Just like human babies, Mosasaur hatch into walking more upright on their two hind limbs. The deeper paleontologists can look into each new bit of bone, the more they can unravel precious details about the past. That means they've had to seriously scale up their tools. And what I'm about to read next is so cool. So, all of it's cool. It's about dinosaurs. In northwestern corner of Grenoble, France, on a triangular spit of land where two rivers meet, a gray ring half a mile around rises out of the smog. It's as if aliens had touched down in the Alps for some skiing and a spot of fondue. The eerie structure is the European Synchrotron Radiation Facility, which in recent years has become a mecca for paleontologists, thanks to staff researcher Paul Taforo. The ESRF is a particle accelerator that flings electrons around at nearly the speed of light. As the electron beam makes its laps, magnets along the circular track bend the particle stream. The disruption makes the particle give off some of the world's most intense X-rays, which researchers can often use to study new materials and medicines. Tafaro has used the X-rays to look inside fossils that typical CT scanners can't make sense of, at resolutions those scanners can't reach. In a display case are 3D printed examples of past fossils he's X-rayed. Portions of them, a burrow more than 250 years old, were scanned finely enough to resolve detail as narrow as a human red blood cell. That's insane. When conditions are just right, Tafaro scans can show features less than 1/100th of a width. I can't even imagine how small that is. Such is the power of a magnifying glass the size of a football stadium. Okay, well, I guess that helps. With great power, though, comes great responsibility. To illustrate the importance of safety to a new student, Tafaro uses an unfiltered beam to light objects on fire and roast coffee beans. Most of the beams we are using to scan fossils would kill you in just a few seconds, he says. The ESRF's intensity has worked wonders for Dennis Foten of Sweden's Uppsala University, who used it to virtually slice through Archaeopteryx fossils and trace out the cross-sections of the bones in exacting detail. Because bones must withstand the strain of flight, their geometric structure can speak to the animal's flying styles. Though Archaeopteryx's anatomy didn't allow for a fully bird-like flap, the cross-sections of its wing bones here closely resemble those in living pheasants, which are ground birds, which fly in short bursts. It's a striking hint at how the 150 million year old creature, an iconic snapshot of dinosaurs' evolution into birds, navigated the Jurassic island chains it may have once called home. Kimmy Chappell of South Africa's University of the Witwatersrand has used the facility to look inside some of the world's oldest known dinosaur eggs, those of the southern African herbivore Massaspondylus, displays let her reconstruct the embryonic skulls inside down to tiny teeth the dinosaur would have either shed or reabsorbed before hatching. Modern gecko embryos also have these proto-teeth. Despite the fact that geckos and dinosaurs' last common ancestor lived more than 250 million years ago. So, thanks in part to the geckos, Chappelle figured out that the Massospondylus embryos made it 3/5 of the way through their incubation before dying, unfortunately. An intimate glimpse into the lives cut short more than 200 million years ago. That makes them feel much more real, she says. And I think this right here is a picture. Absolutely fascinating. You can see here its eye and its body here. All of this was done with a particle generator. It's insane what we're using in science now. Just for dinosaurs. Isn't that amazing that dinosaurs just, you can delve into so many different areas of science and use their resources, different techniques, all for the sake of our beloved dinosaurs. Feathered fossils from remarkable sites around the world preserve vestiges of all kinds of tissue. In 2014, researchers announced they had found an Edmontosaurus regalis, a type of hadrosaur in western Canada that has a coxcomb of mummified flesh, like what you'd see on a rooster. This is a structure nobody knew that a dinosaur had, despite knowing of the species for nearly a century. Dinosaurs' bones had shown that the creatures used exaggerated body parts to woo mates and jockey for social status, just like modern animals to find their kin. With Edmontosaurus and other dinosaurs bearing soft tissues, paleontologists are seeing hints of these displays' true splendor. In a few cases, researchers can even infer some of the animal's original chemistries. In 2008, scientists led by paleontologist Jacob Vinter, now of the UK's University of Bristol, figured out that melanosomes, tiny subcellular sacs filled with the pigment melanin, could fossilize. The discovery opened up the door to a field once thought impossible, figuring out the colors of extinct dinosaur skin. Isn't that so exciting? And feathers based on the shapes, sizes, and arrangements of their melanosomes. These reconstructions come with caveats. Living animals employ other pigments besides melanin, and some extinct dinosaurs probably did too. Even so, recent finds have been more astonishing. The feathered dinosaur Anchiornis, which lived in what is now China, had a reddish crest. The early ceratopsian Psittacosaurus had red-brown skin that contributed to an early form of dino camouflage. In 2018, an international team reported that the feathers of Kaihong, I know I'm going to say that one wrong, a dinosaur that lived in the same region as Yichi, which I know how to pronounce, once shimmered with all the colors of the rainbow. I'm not sure if it's going to mention it here, but we also know the color of Microraptor is similar to like black iridescence like crows. That was like one of the more famous ones that we came across first. I love how I say we, like I made the discovery, but I feel like I'm a part of it somehow. Even more of life's molecules may last through deep time. In the 2000s, North Carolina State University paleontologist Mary Schweitzer made waves when she found that some dinosaur fossils, including T-Rex specimens, contained preserved cells, blood vessels, and maybe even vestiges of proteins. Ever since, Schweitzer and a growing cohort of scientists have asked how such substances could persist and what we could learn from them. More than anything else, scientific advances show us that dinosaurs weren't the one-note menaces that we sometimes see in popular culture. They courted each other with elaborate displays and squabbled for social status. They suffered broken bones and infections. They snapped after bugs and nibbled on ferns. Their days were as rich and varied, frenzied and humdrum as those of the birds outside our windows. Even the biggest, fattest T-Rex sometimes took a nap. Wow, what a sweet way to end that section. I didn't read this far, so that is so cute because, yeah, as you can see here, we've got these beautiful, Edmontosaurs. And their red crests up here. Because on the fossil skulls, I recently was up at the Royal Tyrrell Museum. And on the fossils themselves, they don't have any kind of crest. It's just a head, so that's so cool. Yeah, advances in 3D technology allow looks at brain regions and other soft tissue structures. From such views, researchers think large hadrosaurs, like these fighting Edmontosaurus bulls, may have communicated via low rumbling sounds. So before we move on to the last article about Spinosaurus, I wanted to come back to the dinosaur brains, how they socialized, how our thinking has changed. Scientists long wondered what purpose the bizarre, bony crests of Lambeosaurus served. It was one thought that the convoluted nasal passages enhanced smell, and now it's believed the crests were a vocalization instrument similar to the way elongated trachea of today's trumpeter swans work. So, constructive crests. Studies of the inner ear of Lambeosaurus find that they were the right size to have heard frequencies created by the nasal cavities of this group's crests. This supports the hypothesis that the crests were used for making sounds, as opposed to disproved theories including that they worked like snorkels for underwater dives. I don't know why in the beginning everybody just thought, it's gotta live in the water. Like the famous depictions of sauropods, just peeking their long necks out of water. But it's amazing how far we've come in this science. And it wasn't even that long ago, a couple hundred years ago. Reconstructing a brain. Computer modeling shows how nasal tubes can enhance low sounds. Scans of the inner ear and brain anatomy tell us that not only would Lambeosaurs have been able to hear these sounds, but their high-functioning brain regions could interpret complex behavior. So we have a nice... Here, I'll see if I can get y'all a little close up here. So, there's the olfactory bulb for smell on the top, the cerebral hemisphere for complex thought, and the brain is right behind the nasal chamber here. It seems like it's attached. And then they have the inner ear here. How they heard. In birds, the length of the basilar much, Leah, correlates with the range of frequencies they can best hear. With that clue, experts think dinosaurs heard lower frequencies best. And most likely, since they, could hear lower, they would sound lower too. Like they would make lower rumbling noises. I mean, obviously it just makes sense. But it's just cool to think about. Good at complex behavior. Brain scans found cerebral hemispheres involved in higher level processing, such as interpreting social cues, made up by some 40% of the Lambeosaur's brain, more than nearly all other dinosaurs. So this is alluding to, the research being that Lambeosaurs and, probably other duckbill hadrosaurs relied very much on socialization, which is, it would make total sense, right? Thinking about it, how their crests would evolve to make such complex noises, if being social was very important to them. So everything that we learn is all starting to make sense. But what's amazing is that we'll still never know 100% for sure until we can have one right in front of us. So let's get to the meat and the fantastic finale of this part of the video. So let me know if you guys want a part two, because I would be happy to read the rest of it. Let me know in the comments. Introducing, drumroll, Spinosaurus. 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 The heron from hell. In an academic tussle about Spinosaurus, it emerges that the fearsome beast likely wasn't much of a swimmer. Oh, the controversy that this dinosaur goes through. If you are not deeply ingrained in the paleosphere and keep up with the papers, or know people who keep up with the papers, like me in this instance, this dinosaur, Spinosaurus, which is a theropod, has gone through so many different changes physically, as well as, proposed things on how it lived, how it functioned. Was it a dinosaur that was close to the water and stuck its snout in the water, or did it swim? What's the density of the bones, all of that. I attended a talk a couple years ago at this point, where one of the researchers were talking about, just the different theories, just based on the bones that they have. But so that's enough of my take on it. Let's get into the article. There's a scene at the climax of Jurassic Park 3. Of course, I haven't read this now, by the way. We're caught up. Jurassic Park 3. That University of Chicago paleontologist and National Geographic explorer Paul Sereno insists is all wet. It's when the dinosaur Spinosaurus aegypticus, the arch-villain of the movie, surfaces in the river on a forbidden island to attack a boat, with only the top of its back showing in the darkness and rain. It's a great scene, Sereno says, but it's wrong. We can't justify it with science. Contrary to some of what's been published about Spinosaurus, which lived in North Africa roughly between 96 and 98 million years ago, in the Kemkem beds, new studies by Sereno and his colleagues in eLife and PLOS ONE claim that the dinosaur was a poor surface swimmer. surface swimmer, that could not dive underwater. Instead, the researchers argue Spinosaurus was a wading creature that kept its feet on the ground, or at least on a riverbed, in relatively shallow water as it hunted for giant fish. A heron from hell, says Serino. The extraordinary holotype, first specimen of Spinosaurus aegypticus, found over a century ago, indicated the dinosaur ate fish, and research published in Nature in 2022 suggested that its dense, solid limb bones showed it was a diver capable of pursuing fish underwater like a crocodile. But Serino says the Nature study failed to take into the account that many air pockets within the body of the giant beast that would have caused it to float like an ice cube. They were agile in the shallows because of their buoyancy, he says, but Spinosaurus was simply not stable enough to be a good swimmer. Spinosaurus aegypticus, just a quick note, I love how all the other ones didn't get their full maiden name here. Scientific name, you know. But Spinosaurus is such an icon, and the treatment it gets, it's like up there with T-Rex. So, you know, Spinosaurus aegypticus was first described by the German paleontologist Ernst Stromer in 1915 from bones discovered in Egypt from its piercing and snarling teeth. He interpreted it as a fish-eating behemoth. But most notable were the extended spines along its back, some of which, and we'll just take a quick look at this wonderful artwork first, before we continue. And as you can see, it is catching a large fish. I'm not sure who the artist is, but I know that everybody is credited in the back. So, there's also some quick stats. Length 45 feet, weight 8 tons, mode of movement bipedal, walking, so on 2 feet. Distinguishing features: 15-foot long paddle-shaped tail, plus a 7-foot sail on its back. Yep. Yep, that's it. But I think, yeah, Spinosaurus is one of the most recognizable dinosaurs, in my opinion. So, but most notable were the extended spines along its back, some of which shot skyward more than 5 feet and together formed a sail similar to those seen on some modern lizards, such as crested and common basilisks from Central and South America, and sailfin lizards from Indonesia, New Guinea, and the Philippines. Sadly for science, the Spinosaurus aegypticus bones were destroyed in 1944 during a British bombing raid on the German city of Munich, where they adorned a wall in a natural history museum. Detailed drawings of the bones remain. However, in 2014, a stunning new partial skeleton from Morocco, revealed in Science by paleontologist and National Geographic explorer Nizar Ibrahim of the University of Portsmouth, with a team including Serino and evolutionary biologist Matteo Fabri, now at Johns Hopkins University, became the neotype, replacing its first found kin. Most of the skeleton had been discovered in 2008. Amazingly, its tail was dug up 6 years later. Bones and teeth from several more Spinosaurus specimens have also been found in North Africa. The second skeleton revealed more details about Spinosaurus aegypticus, especially the discovery of its sail-topped tail. And digging region's fossil-rich sandstone, generating a steady trickle of Spinosaurus bones to fill in the puzzle pieces that are still missing. The new studies by Serino and colleagues are the latest salvos in an academic battle. Spinosaurus did dive, as in Jurassic Park 3 versus Spinosaurus didn't dive. And Team Spinosaurus did dive isn't about to give that up. I obviously stand with the paper we published, says Serino's former co-author Fabry, who's on the Did Dive team and was the lead author of the 2022 Nature study. He argues that the density of surviving Spinosaurus bones matches those of modern animals, such as hippos, that can dive. And he rejects claims that the analysis used in the study were flawed. Just before I continue, the paleontologist community is so full of drama. Some people on the outside would think that dinosaurs are dumb and stupid and don't matter. This is very serious stuff. Okay, I just want to get that straight. People will fight over this, okay? And for good reason. It doesn't matter if we run the analysis using their suggestion or in our way. The results remain the same, Fabry says, which would mean Spinosaurus was capable of diving. So, I know I keep stopping, but let me know in the comments, okay? Are you on Team Spinosaurus waded in shallow waters and was good in shallow waters? So, Team didn't dive? Or are you on the side of, oh well, the bones seem dense enough to allow them to dive in water like hippos? So yeah, let me know in the comments if you are Team Dive or Team Not Diving. I will not say mine because I don't really have a side. If I had to choose one, I would probably say the wading, like shallow water. So no diving, but who knows? There's a new paper coming out soon this year, so we shall see what the updates are. And Serino counters that while he waits for Fabry's reanalysis. Yet another study that his team is soon to release based on the bones they've just discovered from a new Spinosaurus species. Oh, yes, that's what the paper is going to be about. Will strengthen the case that the dinosaur could not dive. This latest specimen was unearthed in Niger, on the southern side of the Sahara, in a landscape that was probably a wetland fed by large rivers, then hundreds of miles away from any ocean. Okay, see? It's all coming together. This species also sports a large, knife-like crest atop its skull. Serino and his colleagues reason that the crest, like its gigantic sail, was used for display, to intimidate rivals or to attract mates. That's how they're used by living lizards, Serino says. Whether it swam like a fish or snatched prey while wading, Spinosaurus was a fearsome beast. A fully grown Spinosaurus weighs as much as 10 tons, stood more than 14 feet tall to the top of its dorsal sail, and reached a body length of 45 feet, Serino says. Its crocodile-shaped skull grew to 5 feet in length, and its jaw was lined with protruding, interlocking teeth, perfect for catching fish. It also had extremely powerful forelimbs with curved, blade-like claws for hooking and slicing slippery prey, like fish. But Serino would not speculate whether Spinosaurus or Tyrannosaurus would have won a pitched battle. One scene in Jurassic Park 3 has Spinosaurus snapping the neck of a Tyrannosaurus, cementing its reputation as the biggest and baddest dinosaur of them all. The Tyrannosaurus first appeared in North America about 68 million years ago, some 25 million years after. You heard that? After Spinosaurus went extinct in Africa. Two lovers destined to never meet. They're both titanic animals, but they never saw each other. Serino explains they were living on different continents at different times. And here we have a Spinosaurus fluted cranial crest, the most unique bone in its body, from a valley in Morocco's Kemkem Badlands in 1995. So yeah, this is the Spinosaurus crest. Just right on the top of its head. Look at that wonderful porous details, the striations in the fossils. Alright, I think we've got... Oh wow. Look at that. And see, there's the crest. That's just a little model. And then there's the actual one behind it. And what's also cool about Spinosaurus is that it has this little notch that was supposedly, in addition to its teeth, used for, catching fish and other things. Crocodiles, alligators have something similar in structure. Look at those gnarly teeth. Look at all of these teeth. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And dinosaurs replaced their teeth as well. So, that's also why we find a lot of teeth. So, yeah, Spinosaurus skull, a well-preserved cranial crest discovered by Serino, is held in his hand above that species skull, showing that its long snout was habitually held angling downward in fishing positions. I believe it, man. So, I think, I'm not sure if, okay, we've got a couple more pages, and I think what we're gonna do instead is we will end it. Sorry, Serena. We'll end it with dino eggs show their true colors. Yeah, so it's just a couple of pages, and I think it will be a wonderful end to this video. So here we've got a Spinosaurus skeleton here. Workers grind the rough edges off a life-size polystyrene resin and steel Spinosaurus skeleton created from a computer model that used CT scans of fossils, images of lost bones, and extrapolations from related creatures. So, since we do not have a full skeleton, they are filling in some of the pieces as best they can to kind of reconstruct the whole animal. So, Spinosaurus is like any other dinosaur, always changing unless we find a full skeleton, on the first or second go. Alright, so for the last article, we'll be reading Dino Eggs Show Their True Colors. And over here we have 1, 2, 3, 4, 5, 6 beautiful eggs. One appears brown, green, blue, and brown. So, a wide variety. A laser treatment hints at the hues dinosaurs could and couldn't see. That affected the eggs they laid and tried to camouflage for survival. At her lab in New Haven, Connecticut, Jasmina Feynman, a Yale PhD candidate in 2020, grinds up a small piece of Allosaurus bone for analysis. Feynman transfers the dust into a tube and adds an acid solution, which fizzes and turns a deep shade of brown. Fizzes, fizzes, fizzes. It reminds me always a little bit of Coca-Cola, she says. Under a microscope, the gunk left behind includes spongy mahogany chunks shot through with black squiggles. Squiggles. The brown schmutz was once a protein-rich tissue. The squiggles, the outlines of bone cells that lived more than 145 million years ago in a toothy Jurassic predator as long as a school bus. After millions of years, heat and pressure often will transform these kinds of microscopic remains through chemical reactions. Despite their altered state, the materials hold invaluable clues to dinosaur behavior. In a 2018 study, Feynman showed that when certain dinosaur eggshells are struck with a laser, the light that scatters back reveals degraded, big word here, protoporphyrin. Protoporphyrin or protoporphyrin. I'm not sure. And biliverdin. Or biliverdin. Compounds that give modern bird eggs color and speckling. Fossil eggs from Mosasaurus left. So this one here show chemical traits of being soft rather than calcified and would have likely been buried in soil or sand. Deinonychus eggs had a bluish hue, suggesting that, like modern birds with similarly colorful eggs, it brooded its young. Based on such analysis, the calcified eggs of the velociraptor relative Deinonychus had a bluish hue, suggesting that, like modern birds with similarly colorful eggs, the dinosaur had open-air nests and brooded its young. By contrast, fossilized Protoceratops embryos, which is a ceratopsian, and Mosasaurus embryos from Patagonia are surrounded by what was once leathery eggshell, according to a study Feynman co-authored in 2020. I did not know that. That is so cool. The find suggests not only that these dinosaurs buried their nests like modern sea turtles do, but also that this first dinosaur's eggs were similarly soft. That adds a twist to dinosaurs' evolutionary story, since it implies hard eggshells, which are found throughout the group Dinosauria, must not have a common origin. Instead, the trait evolved at least 3 times. So, how they hatched? Colored eggs. We've got this nice egg right here, which is a fossilized bird egg. Okay, the extinction of the non-avian dinosaurs helps researchers analyze the chemistry of more ancient eggshells. So I'm not going to read this in detail, but there is a Deinonychus egg. And then there is a little chart here, kind of like a timeline of a family tree, where it's showing that first known eggs were soft, split off, and emerged in Dinosauria 232 million years ago. And then later, egg color originates in the Humanoraptora. And then it led to all of these different shapes and sizes of eggs. our thinking has changed. Previous theories about dinosaur reproduction relied heavily on our understanding of reptile eggs. Scientists have since established a solid evolutionary connection between dinosaurs and birds. One that is yielding better clues to how dinosaurs laid eggs and cared for their young. Now, if you're not familiar, dinosaurs are birds. They are still reptiles, but then that also means that birds are reptiles. The way that things are named and families broken up and all that, I'm not an expert on, but I think that is just so cool that it's birds are reptiles, dinosaurs are birds. Roosting. Modern birds with hard-shelled eggs usually brood their young in open nests. The behavior may have evolved when coloration did 157 million years ago. Buried nests. Some dinosaurs, such as Protoceratops, had eggs with soft, leathery shells to protect them. The dinosaurs would have buried their eggs, much as sea turtles do today. Let's bring this a bit closer here. A look inside. No need to crack any dinosaur eggs. Researchers can see inside with CT scans. Embryonic teeth have a deposit that can be counted like tree rings, helping researchers calculate incubation times. That's insane. They found that dinosaur incubation was slower than birds, closer to reptiles. What a journey we have gone on tonight. From reading about all the different ways that scientists are using different techniques like CT scanning, particle generators, to, slice through bone without actually slicing through bone, to Spinosaurus, and did it dive? Did it not dive? Let me know in the comments what you think. Yeah. And also, that dinosaur eggs, some of them were colorful, and some of them had different textures, like hard or soft and leathery. Absolutely fascinating animals. That I love that we are in a golden age of discovery. And as you can see, there is a lot more to read. A lot more that we can learn together and discover, because I have not read part 2 yet. Thank you all so much for watching this paleo ASMR video. I loved reading through this, and I learned some things along the way. I hope you did as well. It's probably not an if. I'm going to be reading part 2, some articles in part 2. Let me know if you enjoyed it in the comments. I asked a lot of things to be said in the comments, so just choose whatever you want. But I would love to know if you guys enjoyed this. I enjoyed reading it to you. And if you would like to see more of my stuff, my Instagram, @GummyDragon with 3 M's. I post all of my dinosaur artwork on there. And if you happen to like anything that you see, I have an online shop where I sell all of my little cute prehistory items. So, thank you all. Thank you